Section 2.1 is on organizing data. What we have is in this chapter, we have raw data. So we're going to organize it into two types of distribution. It depends on the type of data that we have. So what we have here, the two types of distributions we have are categorical data and group frequency distribution. When do we use the categorical frequency distribution? We use a categorical frequency distribution when the data is a qualitative data. What does it mean by qualitative data? If I ask you, what's your favorite ice cream flavor? You tell me vanilla, chocolate, strawberry. That's an example of a qualitative data. So how do we construct a categorical frequency distribution for qualitative data? Our first column, we're going to have class. The second column, we have tally. Third, we have frequency. And the last one, we have percent. So what does it mean by tally? We count how many tally marks that we have. That would be our frequency in numerical value. So let me show you what I mean by that in terms of example 1. 25 Army inductees were given a blood test to determine their blood type. Construct a categorical frequency distribution. All right, so here we have, it tells us in the problem that 25 Army inductees, meaning that N equals to 25. And another way to find the N value, we can count 1, 2, 3, 4, 5. There are 5 data values here, and we have 5 rows of 5. That's how we know N equals to 25. All right, so for the class, we have the blood type. So we have the blood type A, blood type B, blood type O, and blood type AB. Then how do we count our tally marks? So, well, here, A, we're going to look into our data set to collect all the Army inductees with blood type A. So what we see here from our data set, we have 1, 2, 3, 4, 5. So we represent it with 5 tally marks, meaning that the frequency is the numerical value 5, all right? Then to figure out the percent, we take the frequency divided by the total, times it with 100%. So here we have the total N equals to 25. We have our frequency of 5. So I'm going to share my calculator to do the computation here. 5 divided by 5, we have 0.2. Take 0.2 times it by 100. This is how I ended up with 20%. Now, for Army inductees with blood type B, what we have for blood type B, we're going to get the tally and frequency. So likewise, 1, 2, 3, 4, 5, 6, 7. So we should have 7 tally marks for Army inductees with blood type B. As you already know that, tally we do it by groups of 5. So here we have 5 tally marks, 2 more tally marks here. And in the frequency, we're going to say the numerical value of 7. Then what we're going to do, we're going to compute the percent. We take 7 divided by 25, which we get 0.28. We times this by 100, we get 28%. So similarly, you're going to do for the other Army inductees with blood type O and AB, all right? So for O, what we have for O here, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 armies with inductees with blood type O. So we have 5 tally marks plus, 9. I'm missing 1. So we have 5 tally marks with 4 extra tally marks here. That gives us the frequency with the numerical value of 9. Then we take 9, dividing it by 25. And the reason why we divided 25, sorry for the glare, is because our total is 25. After we take 9 divided by 25, we're going to times it by 100, which we get the percent is 36%. And last one we have for AB, what we have for AB here, we have 1, 2, 3, 4, that's it. And notice we collect the entire data already. So we have 4 tally marks, meaning that our numerical value for the frequency would be 4. We're taking 4, dividing it by 25. 4 divided by 25, which we get 0.16. Take 0.16 times by 100, we get 16%. So now, if we were to add up all these percentages, we will get exactly 100%. So that's how we construct a categorical frequency distribution for qualitative data. What we have here on the next page, I provided for you with a practice problem that's very, very similar. So let's take a look at what we have. Trust in internet information. A survey was taken on how much people place in the information they read on internet. Construct again, what the problem is asking us to do here. To construct a categorical frequency distribution for the data, because we have a qualitative data here. A, trust in all, M, trust in most of what they read, trust in about 1/2 of what they read, and trust in a small portion of what they read. All right, so now here we're going to figure out the total. What would be our N value for the data set? Well, we're going to count the number of data points, data values here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since we have 10 in the first row and we have 4 rows, which we expect to see that the total would be 40. All right, then what we have here for our class, we're going to write it down based on the order that's given in the problem. A is trust in all they read, H trust in about 1/2 of what they read, S trust in M trust in most of what they read. So let me go, it doesn't matter the order, but since I said I'm gonna go by the order that's stated in the problem. So M trust in most of what they read, trust in 1/2 of what they read for H, and trust in a small portion of what they read. All right, so now we're going to collect A. Look at our data set here. Let's see how many A's do we have. 1, 2, 3, 4. I believe that's it. So meaning that we have 4 tally marks. So again, because we have 4 tally marks, our frequency would be 4. Then to figure out the percent, frequency dividing by the total, timesing it with 100%. So here, for our total, we know that N equals to 40. We take 4 divided by 40, times it with 100%. Let's do the computation. 4 divided by 4 divided by 40, which we have 0.1, times it by 100%, which tells us that if the pupil trust in all what they read on internet, which is 10%. I wrote an extra 0 here. Okay, then similarly, we're going to go for M. We have a whole lot of M. So let's find out what we have for M here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we have 28 tally marks for M, meaning that we should have 5 groups of 5 and 3 extra tally marks. But since we know how to do that already, I'm going to write it in terms of the frequency 28 here. All right, so on the tally mark, the point of the tally is so that it helps you to keep track. But since we have a whole lot of tally marks with 28 here, so I'm going to just write the numerical value. All right, then we do the computation. 28 divided by 40, timesing it by 100%. When we take 28, dividing it by 40, we get 0.7, times it with 100%, which we have 70%, okay? So this gives us what we have here, 70%, and I should write 10% right here instead of on the top. All right, For age, let's find out what we have for age. For age, we have 1, 2, 3, 4, 5, 6. I believe that's what we have for for age. 1, 2, 3, 4, 5, 6. So the numerical value is 6. Let me collect the rest of the data, making sure I'm not missing anything here. And for S, we have 1, 2, and that's it. And here we have, and we can double check because we expect to see the total is 40. If we're taking 4 plus 28, we have 32 plus 6, 38 plus 2 more, that's 30. So we know that we have collected all our data values and equal to 40. And again, continue to do the computation. Take 6 divided by 40 times it with 100%. So 2 divided by 40 times it with 100%. Okay, so 6 divided by 40, we get 0.15 times it with 100%. This gives us 15%. Okay, then what we have here on the last computation, 2 divided by 40, which is 0.05 times 100%, we ended up with 5%. Okay. All right, so that's how we construct a categorical frequency distribution. Another type of frequency distribution, we said that we have 2 types of frequency distribution. So what we just worked on, we worked on categorical frequency distribution. When do we use group frequency distribution? Or for short, you tend to see that we just say frequency distribution. So meaning that when we don't have the word categorical, then it really means frequency distribution or group frequency distribution. We use frequency distribution for quantitative data. So let me turn the page and I'll show you what we have here. Group frequency distribution or frequency distribution is used when the data is quantitative and the range is large. So for example, if I ask you, how old are you? You would tell me, I'm 18 years old, I'm 20 years old, I'm 30 years old, I'm 50 years old. That's an example of a quantitative data. So we have the data in terms of numerical value. That's when we use a group frequency distribution, or for short, we say frequency distribution. So now, in terms of group frequency distribution, what we have here, we're going to compute the class width. So class width equals to highest value minus lowest value divided by number of classes. The number of classes is always given in the problem. So what this really means is it tells us to break the data into, the number of classes is 5, meaning that to break it up into 5 subgroups. If it tells us the number of classes is 6, that means we'll break the data into 6 subgroups. If it tells us the number of classes is 8, meaning that we're breaking it into 8 subgroups. When we do our class width, we always round it to the next whole number. Okay, so now how to compute our class boundaries? Very, very important. All right, so it depends on the type of data. So let me go back to explain what are the headings that when we construct a frequency distribution for our data. When we construct a frequency distribution, we're going to have these 4 columns here. Rather than class, we're going to have class limits because we have numerical value. We have class boundaries, we have tally and frequency. Now, for class boundaries, depends on the type of data. So there are a couple questions from section 2.1 homework on ALEKS. I'm not going to giving you in terms of the entire data yet. I only give it to you in terms of one class limit and ask you to find the class boundaries. So it depends on the type of data. For whole number data, here's what you're going to do. For whole number data, to find the lower class boundary, you take the lower class limit, you minus 0.5. To find the upper class boundary, you take the upper class limit, you add 0.5. For 1 decimal place data, you still do minus and plus, but you're going to do in terms of 0.05. Okay, that's how you do for class boundaries. And let me go through all these four, and then when I get to an example, I'll show you how to do it. For 2 decimal places data, you're going to do by plus or minus 0.05, and for 3 decimal places data, to find the class boundaries, you're going to do by plus or minus 0.0005. All right, so let me show you an example on how to construct a group frequency distribution. Okay, so example 2, construct a frequency distribution for the data using 8 classes. So the number of classes in this problem is 8 classes, meaning that we divide it up into 8 subgroups, okay? So from our data here, we're going to look for the lowest value. We see that the lowest value from the data set is 5. We're going to look for the highest value from the data set, and we see that the highest value from the data set is 775. From here, we compute the class width. So from our formula, we said that the class width equals to the highest value minus the lowest value divided by the number of classes. So here we have the highest value of 775 minus 5 divided by the number of classes is 8. So here is what we have. 775 minus 5, get the difference of 770, dividing it by 8, which we get the class width of 96.25. Now, when you do the computation, be careful. If you want to do 775 minus 5 divided by 8, don't key in this way. Because when you key in this way, your calculator will treat it that we would have to do 5 divided by 8 first, and then do the subtraction, but that's not what you intended to do. So one way to do it is like how I did it up here. Find the difference first, and then take the result divide, okay? Because if you do it this way, you're not going to get the correct answer. If you wanted to do all in one, then you use parentheses. 775 minus 5, close it, divided by 8. Then now your calculator will perform the subtraction first, because it's inside the parentheses, then do the division. That way you will get the exact answer as how we did it up here, which is 96.25. Okay. Then we said that what we have here, always round the class width to the next whole number. So with raw data like this, Alex will ask you, what's the class width? All right. So 96.25, the next whole number, don't use rounding rule because we're rounding it to the next whole number. Therefore, the class width would be 97, okay? All right, so now let me show you how I actually constructed the class limit here. How you construct the class limit, I know I already have it, type it out the solution for you, but let me show you how I actually got to the solution here. You started off with the lowest value from the data set. So you started with 5, okay? The class width is 97. So what you do here, you take 5, add 97, you get 102, okay? So that means your next class would start at 102. Then you take 102, add 97, your next class will start at 199. Okay, then you take 199, add 97, your next class will start at 296. 296, you add 97, which you get 393. 393, you add 97, which you get 490. 490, you add 97, which you get 587. 587, you add 97, which you get 684. Okay, so that's how I come up with all the lower class limits on here. So now think about it. What you have here, 5 go to what number? And the next class limit you go on to 102. Well, since the next class limit you go on to 102 already, then you must stop one before it. So that means you have to stop at 101. Okay? That's what I mean by use 96 to compute the class limit. So you take 5 add 96, you get 1 at 101. But the shortcut is to figure out all the lower class limits. And after that, you see right here, your third class limit is starting at 199. Then this one has to stop at 198. This one starting at 296. Then this one has to end at 295. This one start at 392, this 393, then this one has to end at 392. This one start at 490, then this one has to end at 489. This one start at 587, then this one has to end at 586. This one start at 684, then it has to end at 683. And the last class limit here, because if you look at from 5 to 101 is 96, right? Then you're going to use 684 at 96. So you would end it at 780. That's how we come up with the class limits. Okay. Now, for class boundaries, since we have whole number data, so what is telling us? What's the rule for class boundaries? For whole number data, to get the lower class boundary, we take the lower class limit, we subtract 0.5. To get the upper class boundary, we take the upper class limit, we add 0.5. So what I'm going to do, I'm going to remind myself that we're going to subtract 0.5. So meaning that if you take 5 minus 0.5, you get 4.5. 102 minus 0.5, you get 101.5. 99 minus 0.5, you get 198.5. 296 minus 0.5, you get 295.5. And you continue to get the rest of the lower class boundaries. For the upper class boundary, you're going to add 0.5. So basically, you take all your upper class limits here, add 0.5 to it, attach 0.5 to it, then you will get the upper class boundaries. All right. Now, how do we collect the tally or the frequency? So what we look at here are first class limits. When we write 5 and this sign here and 101, this means 5 to 101. This does not mean 5 subtract 101. Okay. So now we're going to look inside our data to see how many data values from 5 to 101. So here, 41, 66, sorry, anything in the range from 5 to 5 to 101, you collect it all. Not 169, 36, okay, 64, 61, 13, 77, 77, 27, 5, not 106, 52, 52, 94, 75, not 196, 70, not 132, 28, not 143, but 46. Okay, so here, let's see how many did I select in the group from 5 to 101. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's what we get for the frequency from 5 to 101. And likewise, you're going to continue to look into your data set. How many data values from 102 to 198? Okay, so 102 to 198, you're going to go to here. All right, okay, 198, 183 is part of it. 106, yes. 196, yes. 132, yes. 143, yes. 169 on the first row, yes. So here I selected 6 data values ranging from 102 to 198. That's why the frequency is 6. All right. So you get the idea of doing the problem, and you're going to continue to collect the rest of the data. So instead of doing this problem, I have a practice problem that I would like to explain to you on how to do here. Very, very similar. So what we see from our data set here, the question is asking us to organize the data into a frequency distribution with 6 classes. What does it mean by 6 classes? Meaning that we divided up the data into 6 subgroups, okay? Because it tells us 6 classes here, so the number of classes, we're going to put 6. Now, we're going to look for the lowest data value from the data set. So I spotted that the lowest value is 7. We're going to look for the highest value from the data set. I noticed 36 is the highest value here. So we're going to take 36 minus 7, which we know is 29. And we're going to take 29 divided by 6. Okay. So then now, what we have here, and we have 29 divided by 6. We have 4.833, with the 3 is our repeating decimal. So because for class width for whole number data, this one is straightforward, that we know we're going to round it to 5 because, you know, we have 4.8 here. But now, hypothetically speaking, when you compute the class width and you ended up with 4.1, you still round it up to the next whole number. So 5, okay? All right, so here we started off with the lowest value from the data set, which is 7. Now, we're using the width of 5. So 7 add 5 would be 12. 12 add 5 is 17. 17 add 5 is 22. 22 add 5 is 27. 27 add 5 is 32. That's how we come up with our lower class limits. So now, think about the upper class limit here. We start our second class limit at 12, meaning that our first class limit will have to end at 11. Our third class limit start at 17, meaning that our second class limit has to end at 16. Our fourth class limit start at 22, meaning that we would have to end at 21. Our fifth class limit start at 27, meaning that we have to end at 26. And our last class limit start at 32, meaning that the one before that has to end at 31. So think about it. What do we do here? 7 to 11, that's 4 units. So that means 32, 4 units, this you would end at 36, okay? Then now, to do the class boundaries, again, for whole number data, we do by minus 0.5 to get the lower class boundary and add 0.5 to get the upper class boundary. So we're going to do all the lower class boundaries here. 6.5, 11.5, 16.5, 21.5, 26.5, and 31.5. For the upper class boundaries, we just take these values here and add a 0.5 to the end of it. Okay. Then now, we're going to collect the data values. How many data values are from 7 to 11? Okay, so what we have here, 7 to 11, let's look for 7 to 11. We have 10 on the first row. We have 7 on the second row, meaning that the frequency is 2. How many data values from 12 to 16? 12 to 16, we have a 15, we have a 12, we have a 14, 16 here. Okay, it looks like we have 4. How many data values from 17 to 21? So 17 to 21, we have 18, 20, 18, 18, not 24. We have 20, not 36, 20, 18, not 24, 18, yes, 20, yes. So we're taking all the data values from 17 to 21, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a 9 here. 22 to 26. 22 to 26, meaning that 24, 24, okay? We have 2. 37 to 27 to 31. 27 to 31, we don't have anything from 27 to 31, so that would be 0. 32 to 36, and this is it. This is our last one. So we know, and we can double check here. Adding up our frequencies, 2 plus 4 is 6, 6 plus 9 is 15, 15 plus 3, that's 18. And we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18. We know that we took all the data values and we did not miss anything. So again, that's how we construct a grouped frequency distribution. Okay. So now what I have here, this is more or less what you're going to see in your homework for section 2.1 on ALEKS. You don't have a whole table, you don't have a whole data, but what I gave it to you to start it off with a very basic with just one class limits, okay? Now, what I'm asking you to do here to find the class boundaries, the midpoint, and the class width. So class boundaries, we see that we have whole number here from 58 to 70. So class boundaries, we're going to do by minus 0.5 and plus 0.5, okay? Here's what we get for the class boundary. For midpoint, you would need this formula for midpoint. Midpoint, you take the lower class limit, you add it with the upper class limit and dividing it by 2. So what you have here, lower class limit is 58, added with upper class limit of 70, find the sum of 128, take 128 divided by 2, which you get 64, okay? Now, how to find the class width? Well, here, when we have a set of raw data, we use this formula to find the class width. But when we're given with just one class limit, then this would be what you do here. You take the upper class boundary minus the lower class boundary. So the upper class boundary we found is 70.5 minus the lower class boundary of 57.5. So the width come out to 13. And let me show you how you get what we have here to verify why the class width we always round it up. If we take the upper class boundary of 11.5 minus 6.5, we get exactly 5. And this is our class width. Going back to our previous problem, when we do our computation, we ended up with the class width of 96.25, but why did we round the class width to 97? If you look at this one here, the class width coming from the class boundary, if you take 101.5, which is, this is our upper class boundary, minus our lower class boundary of 4.5, which we ended up with the width of 97. And I can guarantee you that if you take any random class boundaries here and you do the difference between the upper class boundary and the lower class boundaries, I guarantee you will get 97. So let's try this. 489.5, 489.5 minus 392.5, 392.5, I guarantee is a 97. That's why we always round the class width to the next whole number. And the class width coming from the class boundaries. You took the upper class boundary minus the lower class boundary. Okay. Now for example 4, very, very similar with what we have in example 3. The only thing I change here is from whole number to 1 decimal place data. So why don't we write this one down? That the class limit from 58 to 70, this is what we have for whole number. The class limit from 16.8 to 19.2, this would be one decimal place data. And how we can tell? Because we have one digit after the decimal point. Okay, so now for one decimal place data, you will get a homework question in terms of one decimal place data asking you to find the class boundary. And remember, I said this, how to find class boundaries for one decimal place data. We instead of doing it for 0.5 in whole number, in one decimal place data, we're going to do by 0.05. Okay, so then what we see here, we're going to take 16.8 minus 0.05 to get the lower class boundary of 16.75. And let me verify that computation for you. So we have 16.8 minus 0.05, we have 16.75. Then for the upper class boundary, we take 19.2, we add 0.05, we get 19.25, okay? Then for the midpoint and the class width, very much the same as what we did in example 3. Midpoint, you take the lower class limit of 16.8, add it with the upper class limit of 19.2, dividing it by 2. Class width, and again, what to do to get the class width? You take the upper class boundary minus the lower class boundary. So here we see that the upper class boundary we just computed, we ended up with 19.25. Our lower class boundary is 16.75. When we take the difference, we will get 2.5. Okay. All right, so this is an example of whole number data. This is an example of one decimal place data. And what we have here on example 5, we see that we're still looking for class boundaries, midpoint, and width. But in this data, we have 2 digits after the decimal point, meaning that we have 2 decimal places. Okay, so what we see here for 2 decimal places data, how about I say 2 decimal places data? How do we find our class boundaries? Let's revisit to what I said here. For 2 decimal places data, I highlighted in orange that we're going to do by plus and minus 0.005, okay? So we have our lower class limit of 19.36, excuse me, 9.36, we minus 0.005, we get 9.355. Our upper class limit of 13.24, we're going to add 0.005, we get 13.245. That's how we come up with our class boundaries, okay? Midpoint, we've been doing it for the last couple examples. Class width again, class width coming from class boundaries. So I'm going to just highlight the formula here for you, okay? Now, sometimes we have ungrouped frequency distribution. When do we have ungrouped? When the data is very small. So if you look at what you see from our data set here, we see that our data value ranging from 0 to 7, which is very small, compared to our raw data earlier here, ranging from 7 to 36. And this one right here on our example, we have our data value ranging from 7 to 775. Okay. So now how do we do for ungrouped data? Okay. So ungrouped frequency distribution when the range of the data value is relatively small. Okay. So ungrouped frequency distribution when the data values are relatively small, a frequency distribution can be constructed using single data values for each class. And what you notice, we have class limit of single data values from the data set here. And we see the data set has single data values from 0 to 7, okay? This type of distribution is called an ungrouped frequency distribution. So let's take a look at what I have for this last example for our lesson here. A survey was taken with 40 individuals, so meaning that we know n equal to 40, okay? And another way we find out what our n value, we count the number of data values, 1, 2, 3, 4, 5, 6, 7, 8, and we have 5 columns. So 5 columns of 8, that gives us 40. They were asked how many times per week they ate at a fast food restaurant. So we have from 0 ranking to 7. Construct a frequency distribution using 8 classes. So what we have here, we have from 0 to 7, that's 8. And what you notice, our data is a whole number data. So therefore, for whole number, we are coming back to minus 0.5 and plus 0.5. So we take the number here, we minus 0.5, we get negative 0.5, add 0.5, we get positive 0.5. We take the number 1 minus 0.5, we get 0.5. We take the number 1, add 0.5, we get 1.5. We take the number 2 minus 0.5, we get 1.5. We add 0.5 to 2, we get 2.5, and so on. Then we're going to do for the rest of the class boundaries. For frequency, you just select how many data values of 0. So here we have 2, that's why the frequency of 2. How many data values of 1? So 1, 2, 3, 4, that's it, okay? And then continue the rest for our frequency column. Part B, based on the distribution, so assuming that we complete our frequency distribution, based on the frequency distribution, how often did most people, so you're looking for the one with the highest frequency, so the most we see here is for frequency of 20, and how often, that would be 2 times a week, okay? How often did most people eat at a fast food restaurant? So it would be 2 days a week. All right, so now for your homework for section 2.1, I made the assignment very basic compared to the lesson because the lesson I gave you raw data, but this will help you with section 2.2 because it's the first section in your homework assignment. So that's why I made it very basic, but you're going to find that section 2.1 is very helpful when you get to 2.2. Thank you so much for watching, and I will go on to do the next video on section 2.2.